You can recall this f dash h, that is equal to limit k tends to 0, f of h plus k, this. Now if you put k equal to x minus h, you will get that one, h tends to 0 minus, h tends to 0 minus means less than 0, therefore 1 plus h will be less than 1. You calculate yourself following the same steps, only you are to write here h tends to 0 plus, h tends to 0 plus. Now next problem, question number 11. If fx is differentiable at x equal to h, find the value of this one. Number 11. Here we have to find the limiting value of this, and the extra condition is it is differentiable at x equal to h. We start like this. Since fx is differentiable at x equal to h, already it is discussed that f dash a, that means derivative of fx at certain point x equal to a, will be the limit. Therefore f dash h limit I take this one, now if I take k a small number, then f dash h is equal to, sorry, we have to replace, this is not a, h. Now if we put x minus h equal to k, then this will get new form. Now fx is differentiable, therefore as per definition this is. Now we have to calculate this one. I write this expression first on the right side when space is insufficient. Now limit x tends to h, numerator x plus h fx minus 2 h fh by x minus h. Limit x tends to h, I found x minus h plus 2h. Actually denominator is x minus h. To get that, I write x plus h like this form into fx minus 2h fh by x minus h. Now this is limit x tends to h. I take this part, x minus h into fx plus 2h fx minus 2h fh divided by x minus h. 2h fx 2h this one. Then this becomes limit x tends to h, x minus h into fx. 2h is common factor. 2h fx minus fh. I put third bracket divided by x minus h. Limit x tends to h, this part by this part, x minus h whole into fx divided by x minus h plus h is constant, therefore this 2h can be taken out. Limit x tends to h fx minus fh by x minus h. Now for this part, these two can be cancelled since x is not equal to h, and this is the definition of f dash h. Therefore this is fh limit x tends to h fx, that is fh plus 2h into, this is f dash h as per definition, f dash h. You can recall this f dash h, that is equal to limit k tends to 0 f of h plus k, this. Now if you put k equal to x minus h, you will get that one. Therefore finally we get, therefore given limit is this. We follow as per definition of the derivative of a function at a certain point, x equal to h, this will be f dash h, and this one. Now if we put h plus k, that is equal to say x, then we get this one fx minus fh by k means x minus h. Let me deduce that one, putting h plus k equal to x, therefore x tends to h as k tends to 0. That means you get the form limit x tends to h fx minus fh, that is by k equal to x minus h. This is the transformed form of f dash h. I have applied this one here. Then I have written the given limit in this form and simplified. Final step is this one. I have put the value and got the value of the given limit, this one. Next, number 12. For that, I am to rub this one. Finally, this one. Limit x tends to 2, this one. Given limit is equal to limit x tends to 2 x f2 minus 2 fx by x minus 2. Since denominator is x minus 2, I write in place of x, x minus 2 and adjust. That will be limit x tends to 2 x minus 2 plus 2, see this, into f2 minus 2 fx whole divided by x minus 2. That will be equal to limit x tends to 2 x minus 2 into f2 plus 2 f2 minus 2 fx divided by x minus 2. Now I take this part, x minus 2 into f2 divided by x minus 2 first, then taking minus 2 common factor, etc. That means the step will be limit x tends to 2 x minus 2 f2 by x minus 2, this one, plus I take minus 2, rather minus 2 limit x tends to 2 fx minus f2 by x minus 2. As I have discussed, this is f dash 2 and here x minus 2 are cancelled. Here x is not equal to 2, therefore we can cancel from numerator and denominator. Therefore finally we get this is f2, that is constant, therefore limit x tends to 2, f2 means f2 minus 2, limit x tends to, this is f dash 2. Now we see f2, value of f2 is given, also f dash 2 given, therefore I put the value f2 equal to 4 minus 2 into 1, that means finally this one. Here we have used the definition of f dash a, that means derivative of fx at certain point x equal to a. Therefore the sum is solved, value will be 2. Now sum number 30. Here we have to use that concept of limit. We have to find whether it is differentiable at x equal to 1. That means we have to find left hand derivative as well as right hand derivative at x equal to 1. First we see given function y is of cosine form and this value for x not equal to 1. Now let us see whether y can be simplified. This part can be simplified. Solution. Now we find this can be resolved into factors. Therefore, x square minus 4x plus 3 equal to x minus 3, x minus 1, and x square plus 2x minus 3, x square plus 3x minus x minus 3, that is equal to x into x plus 3 minus 1 x plus 3, that is equal to x plus 3 into x minus 1. Here we find numerator denominator both can be resolved. I have simplified both. Therefore, when x is not equal to 1, y is equal to what we find x minus 3 into x minus 1, denominator is x plus 3 into x minus 1. X is not equal to 1, therefore I can cancel these two. Finally, form is x minus 3 by x plus 3. Now, for differentiability, therefore, L f dash 1 limit h tends to 0 minus fx. This is fx, of course. If x 1 1 plus h minus f1 by h. As per definition, this one h tends to 0 minus. H tends to 0 minus means less than 0. Therefore, 1 plus h will be less than 1. For that, limit h tends to 0 minus. In this place, value will be this one. In place of x, we have to put 1 plus h. That means 1 plus h minus 3 by 1 plus h plus 3, and f1 already given, that is equal to minus half. Therefore, this is half by h. As h tends to 0 minus, and also for not x not equal to 1, we have to use this simplified form. Therefore, we find the limit h tends to 0 minus. Into 1 plus h plus 4 numerator will be, this is h minus 2, 2 into h minus 2 plus h plus 4. Simplified, and this is h, limit h tends to 0 minus 2h minus 4, 4 cancelled, 2h plus h, 3h, and 2h into h plus 4. h into this part, we get this one. Now h non-zero, therefore I can cancel. Mention h not equal to 0. Therefore we get this is equal to 3 by 2 into, in place of h we have to finally put 0, 4. Therefore 3 by 8. When h tends to 0 minus, I have calculated the left hand derivative. Similarly, since here x is not equal to 1, we have to use the same expression for f of 1 plus h minus f1 divided by h when h tends to 0 plus. Similarly, R f dash 1, you calculate yourself following the same steps, only you have to write here h tends to 0 plus, h tends to 0 plus, and final step, final result will be 3 by 8. Thus what we find, therefore left hand derivative at x equal to 1 is equal to right hand derivative at x equal to 1 same finite value. Therefore f dash 1 or dy dx at x equal to 1 exists, and f dash 1 will be this value 3 by 8. Answer. Here we have used definition of derivative at certain point and calculated the given sum. The dy dx at x equal to 1 will be 3 by 8. Hence the sum is solved. Thank you.